Welcome to our comprehensive Python interview prep series. Whether you're aiming for Google, Meta, Amazon, or any top tech company, mastering Python interview questions is essential. In this video, we'll walk through 50 questions, ranging from basic to advanced, covering core concepts, practical coding, and real-world scenarios. We'll start with fundamentals every developer must know, then move to intermediate patterns and advanced topics. By the end, you'll have a clear understanding of what interviewers expect and how to answer confidently. Let's dive in and unlock your Python potential. Python is a high-level, interpreted language known for its clean syntax and versatility. Its popularity stems from a gentle learning curve, vast libraries, and applications in AI, web development, automation, and data science. Python supports multiple paradigms, procedural, object-oriented, and functional, making it adaptable for various tasks. Companies like Google and Amazon value Python for its readability and rapid development capabilities. If you're starting out, Python's ecosystem and community support make it an ideal choice for both beginners and experts. Python is both interpreted and compiled. When you run a Python script, the source code is first compiled into bytecode, PIC files, which is then interpreted by the Python Virtual Machine, PVM. CPython, the standard implementation, compiles and interprets code, while alternatives like PyPy use just-in-time, JIT, compilation for faster execution. This hybrid approach allows Python to be flexible and portable, but also means performance can vary depending on the implementation. Understanding this distinction helps you optimize code and troubleshoot performance issues. Python offers a variety of built-in data types: int, float, complex for numbers, str for text, bool for logical values, list for mutable sequences, tuple for immutable sequences, set for unique, unordered items, dict for key-value pairs, and none type. Everything in Python is an object, which means you can use methods and properties on these types. Understanding these data types is crucial for writing efficient, readable code and for answering interview questions about data manipulation. Lists and tuples are both sequence types, but lists are mutable. You can change their contents after creation. Tuples are immutable, meaning their contents cannot be altered. Lists use square brackets, while tuples use parentheses. Tuples are faster and use less memory, making them ideal for fixed data and as dictionary keys. Knowing when to use each can impact performance and code safety, especially in large-scale applications. Python args allows functions to accept any number of positional arguments, while **quargs accepts any number of keyword arguments. Args collects arguments into a tuple and quargs into a dictionary. This flexibility is essential for creating generic APIs and decorators, enabling functions to handle varying input without strict parameter definitions. Mastering args and **quargs is a must for advanced Python programming and interview success. Lambda function is an anonymous single-expression function defined with the lambda keyword. It's perfect for short throwaway operations, especially as arguments to functions like map, filter, and sorted. Lambda functions can take any number of parameters, but only one expression, making them concise and readable. Understanding lambdas is key for writing Pythonic code and handling functional programming tasks. Python distinguishes between mutable and immutable types. Immutable types like int, float, str, tuple, and bool cannot be changed after creation. Mutable types such as list, dict, set, and byte array can be modified in place. This distinction affects function arguments, side effects, and dictionary keys. Understanding mutability helps you avoid common bugs and write safer, more predictable code. It handles memory automatically using reference counting and a cyclic garbage collector. Each object tracks how many references point to it. When the count drops to 0, memory is freed. For circular references, the GC module steps in to clean up. Understanding memory management is vital for optimizing performance and preventing memory leaks, especially in large applications. Decorator is a function that wraps another function, adding extra behavior like logging, timing, authentication, or caching. Decorators implement the decorator design pattern and are widely used in frameworks and libraries. Understanding how to create and use decorators is crucial for advanced Python development and interview scenarios. Operator checks if two objects have the same value, while is checks if they are the exact same object in memory. Use is for singleton comparisons like none, true, or false. Understanding this distinction is important for writing correct and efficient code, especially when dealing with object identity and value equality. List comprehensions provide a concise way to create lists from iterables. They are faster and more readable than equivalent for loops and support filtering with an optional if clause. List comprehensions are a hallmark of Pythonic code, making data processing efficient and elegant. GIL is a mutex in CPython that allows only one thread to execute Python bytecode at a time. It protects memory management from race conditions, but limits true multithreading for CPU-bound tasks. For parallelism, use multiprocessing. Understanding the GIL is key for writing scalable, performant Python applications. Shallow copy creates a new object but references the same nested objects as the original. A deep copy creates a new object and recursively copies all nested objects. Use copy, deep copy for full independence. Knowing the difference helps prevent bugs when working with complex data structures. Python uses try, except, else finally blocks for exception handling. Multiple except clauses can catch different exceptions. The else block runs only if no exception occurred, and finally always runs regardless. Proper exception handling is essential for robust, error-resistant code. Python's primary built-in data structures are list, tuple, set, and dict. Lists are ordered and mutable, tuples are ordered and immutable, sets are unordered and unique, and dicts are key-value pairs. Each structure has unique performance characteristics, making them suitable for different use cases. The init method is the constructor for Python classes, called automatically when a new instance is created. It initializes the instance's attributes, with self referring to the new object. Understanding init is fundamental for object-oriented programming and interview questions about class design. Python 3 Uxranja no longer exists. Range itself is lazy and memory efficient, returning a range object instead of a list. In Python 2, range returned a list, while Uxranja returned a lazy utter. Understanding this difference is important for writing efficient code, especially with large sequences. Generators are functions that use yield to produce values one at a time, pausing execution between yields. They are memory efficient as they don't store all values in memory. Generators implement the iterator protocol and are ideal for handling large data streams or infinite sequences. Object-oriented programming in Python is built on 4 pillars: encapsulation, inheritance, polymorphism, and abstraction. Encapsulation hides internal data, inheritance allows code reuse, polymorphism enables the same interface for different types, and abstraction hides implementation details. Mastering these concepts is key for designing robust, scalable applications. Class method receives the class as its first argument and can access or modify class state. A static method receives no implicit argument and behaves like a regular function within the class namespace. Neither can access instance state. Understanding these decorators is crucial for designing flexible APIs. AJAX methods, also known as Dunder methods, allow objects to implement Python's built-in protocols. These include arithmetic operators, comparisons, string representation, iteration, and context managers. Custom classes can behave like built-in types by implementing these methods. Context managers automate resource setup and teardown using enter and exit methods. The with statement guarantees cleanup even if an exception occurs. The ContextLib module provides simpler ways to create context managers using generators. This pattern is essential for managing files, database connections, and locks. Closure is a nested function that captures and retains variables from its enclosing scope, even after the outer function has finished executing. Closures are foundational for decorators and functional programming patterns, enabling flexible and reusable code. An iterable is any object that can return an iterator, has iter. An iterator produces items one at a time, has iter and next. Calling iter on an iterable gives an iterator, next, advances it. Understanding this distinction is key for writing loops and custom data structures. Monkey patching is dynamically modifying a class or module at runtime without changing its source code. It's useful for testing, mocking, and quick hotfixes, but should be used sparingly as it can make code hard to debug and maintain. Map applies a function to every item of an iterable. Filter selects items where the function returns true. Reduce cumulatively applies a function to reduce an iterable to a single value. These functions are powerful tools for data processing and functional programming. MRO determines the order Python searches for methods in a class hierarchy with multiple inheritance. Python uses the C3 linearization algorithm, which you can inspect with class name, MRO. Understanding MRO is crucial for debugging and designing complex class hierarchies. Property turns a method into a read-only attribute accessed without parentheses. Combined with @setter and @deleter, it provides controlled access to private attributes while maintaining a clean interface. This is essential for encapsulation and API design. Slots restricts a class to only have listed attributes, preventing the default per instance dict. This reduces memory usage significantly for classes with many instances. Slots are essential for optimizing performance in data-heavy applications. LRU cache is a decorator that memorises a function's results using a least recently used cache. Subsequent calls with the same arguments return cached results instantly. This is useful for optimizing recursive functions and expensive computations. Python supports 4 types of comprehensions: list, set, dict, and generator. All follow similar syntax and are concise, readable, and often faster than equivalent loops. Comprehensions are a hallmark of efficient Pythonic code. Python provides threading, lock, rlock, semaphore, and event for thread synchronization. The with statement ensures locks are always released. The concurrent futures module offers higher-level abstractions. Thread safety is essential for writing reliable, concurrent applications. Multithreading runs multiple threads in a single process sharing memory, but the GIL limits CPU parallelism. Multiprocessing spawns separate processes with their own memory, achieving true CPU parallelism. Use threads for I/O-bound tasks and processes for CPU-bound tasks. Sync_await is Python's native coroutine syntax for asynchronous programming. An async function returns a coroutine and await suspends it until the awaited task completes. The asyncio event loop enables concurrent execution, ideal for I/O-bound tasks. Duck typing is Python's approach to polymorphism. If it walks like a duck and quacks like a duck, it is a duck. Python checks for the presence of methods at runtime rather than checking types explicitly, enabling flexible, loosely coupled code. Metaclass is the class of a class. It controls how classes are created. Type is the default metaclass. Custom metaclasses can intercept class creation to enforce patterns like singleton or ORMs. Understanding metaclasses is key for advanced Python design. Descriptors implement get, set, or delete to control attribute access on classes. They are the mechanism behind at property, at class method, at static method, and ORM fields. Data descriptors, with set, take priority over instance dict. Python's primary garbage collector is reference counting. Circular references can cause memory leaks, so the cyclic garbage collector, GC module, periodically scans for and collects these cycles. Use weakref to avoid holding strong references and prevent leaks. Create a class-based context manager, implement enter for setup and exit for teardown. Exit receives exception info and can suppress exceptions. This pattern is used for managing database connections, locks, and file handles. New is called first and creates the actual object, allocating memory and returning the instance. Init is called second to initialize the instance. Overriding new is needed for immutable types and patterns like singleton. Memoization caches function results for previously seen inputs. A custom implementation uses a dict as a cache keyed by function arguments. For unhashable args, serialize them. This is the core of functools, LIU cache, and is vital for optimizing recursive functions. Python's data model defines how objects interact with the language. Slots replaces the per-instance dict with a fixed array of pointers, reducing memory and improving attribute access speed. This is essential for data-heavy applications. The asyncio event loop is a single-threaded scheduler that manages coroutines, I/O polling, and timers. It runs ready callbacks in a queue, polls for I/O completion, and schedules waiting coroutines when their I/O is ready. Understanding event loops is key for writing scalable async code. Decorator with arguments needs 3 levels of nesting. The outer function accepts arguments and returns a decorator. That decorator accepts the function and returns the wrapper. Functools, wraps preserves the original function's metadata. This pattern is essential for flexible, reusable decorators. Type hints annotate function signatures and variables with expected types. They do not affect runtime behavior but enable static analysis, better IDE support, and serve as documentation. The typing module provides generics, union, optional, and more. New importer module, Python searches sys, path, loads the file, compiles it to bytecode, executes it, and caches it in sys modules. Subsequent imports return the cached module. You can customize import behavior with import hooks for advanced scenarios. ABCs define interfaces that concrete subclasses must implement. They prevent instantiation of incomplete implementations and enable usinstancer checks without Rückwarung full inheritance. ABCs are essential for designing robust, extensible APIs. Python provides cprofil for function-level profiling, tumut for micro-benchmarks, and memory profiler for memory usage. Optimization strategies include algorithmic improvements, caching using built-ins, and Southern/number for bottlenecks. Profiling is essential for writing efficient, scalable applications. Matchcase PEP 634 provides powerful structural pattern matching in Python 3.1+. It can match values, types, structure sequences and mappings, use guards, and match class attributes. This enables clean data processing pipelines and expressive code. Create a custom iterable class Implement iter returns self or separate iterator, and next returns next value or raises stop iteration. This integrates seamlessly with for loops, list, sum, and other constructs that consume iterables. Custom iterators are essential for advanced data processing. We've covered 50 essential Python interview questions, from basic syntax to advanced concepts like mutterclasses and async programming. Review these topics, practice coding, and understand the reasoning behind each answer. Preparation is key, so keep learning, stay curious, and approach interviews with confidence. Good luck on your Python journey.